So the topic that we're going to be discussing today is going to be Unit 1.8, which is Day 2, and we're going to factor quadratics with leading coefficients. So the idea behind this is that we're going to have quadratic expressions that are going to have a leading coefficient that is not just 1. So everything that we were doing before, we had a coefficient of 1 on that first term, but now we're going to look at what happens when it's not 1. And so as we move into our objective kind of mirrors what I just said previously, is that we're going to factor quadratic expressions when a is not equal to 1. And so we're going to determine its binomial factors. So we're still kind of continuing on this finding binomial factors part, where we're going to look for things, we're going to look for those factors. So again, we can kind of tie that into our zeros, we can tie that into, our polynomial functions and everything like that. Now, what we're doing is this seems like a lot of what we're looking at, but the idea is that we have a few steps that we want to go through, and this is not too much different than what we were doing before. Now, before, we still had an expression, and that expression that we had was ax squared plus bx plus c. And so we need to make sure that we are in standard form whenever we do those things. Standard form is going to be, what we need to use. We're still going to identify A, we're going to identify B, and identify C. Remember, those are the coefficients. But this time what we're going to do is we're going to multiply A times C. Now that was in the other directions, but this is going to be more important with what we're going to do before. So we're going to multiply A times C, get a value, and then that's what we're going to find factors of. Just like we did before, we're finding factor pairs that multiply, but then add up to give us a different value. And that same value is going to be B. So we're still going to be working through that. The only thing that's different is we're going to use a method that we call grouping. So we're going to factor by grouping, and I'll show you a little bit exactly what that is, which basically we're going to be using, what we knew previously with using greatest common factors. And, kind of this whole idea of putting together binomials together. And so basically what the goal of what we're going to try to do here is we're going to try to take this middle term, this negative 10x, and try to create two different terms out of that. So instead of having 3 terms, we're going to try to have 4 terms. So when I talk about factoring by grouping, we want to have 4 terms. So we're going to rewrite. So we can try to think of, what 2 numbers would combine to give you negative 10, and we can kind of think of some of the situations there, and not necessarily worry too much about what we're trying to do yet. So one example would be negative 5x minus 5x. So the idea is that if I subtracted those 2 numbers, I would still get negative 10. And what I could do is I could rewrite this expression as 2x squared minus 5x minus 28. So the idea of what we're trying to do is we're going to try to make 4 terms. And by doing that, what we're going to be able to do is group sections or pairs of these terms so that we can kind of work with them, we can manipulate them, and find greatest common factors with them. And so that's kind of what we're going to be looking for. We're going to take that middle term, which that middle term ends up being that value b that we were talking about. And so we're going to use that, and we're going to move into what we call factor by grouping. So now we're going to try to look for an example of this. And so we're going to try to take this particular expression, and we're going to try to factor it by grouping. And, again, the main goal of this is that we're going to get 2 binomial factors out of this. So the idea here is that we're going to have 2 sets of parentheses still. The only difference with this one, since this has a coefficient that's not 1, it's going to be ax and then probably bx. So they both might have a value there that we're going to use. And so where that's going to come from is kind of that initial or that first term, and where we're going to get those pieces to kind of plug into there. So what we're going to try to do here is we're going to try to find common factors and go back to using greatest common factor like we had been before. But again, one of our first steps that we need to take is that we need to identify B and C. And so if we can do that, actually we also need to kind of identify A. And so in this case we have 3, 8, and 4 is A, B, and C. And so if we kind of look at our rules there, our step 1 rule was to multiply A times C. So in this case, what we're going to do is we're going to multiply the outside terms here, And so we're going to multiply those together, and we're going to get an A times C equal to 12. And so what we're doing that's the same but just a little bit differently is that now instead of just using 4 to find our middle term, we're going to use A times C, which is now 12. So what we're going to look for is we're going to look for factor pairs of 12. And so if we write out those factor pairs of 12, we have 1 and 12, we have 2 and 6, and we have 3 and 4, and then that's going to be it for our factor pairs of 12. Now what we need to do is look for those factor pairs, so where A times C is going to give us kind of that value of B. So which of these 3 factor pairs here are going to give us this middle term of 8? And so the only one that can do that is the 2 and 6. And so the idea behind this of what we're going to actually go ahead and do is we're going to take this and we're going to split it apart. So I'm going to replace this 8x with this 2 and 6, and this is how I'm going to do that. So I'm going to take this equation, I'm going to replace it with that kind of that 6 and 2 that I've been kind of talking about. And so the idea here is what's going to happen is the first term stays the same, and then I'm going to say plus 2x plus 6x, and then plus 4. So notice that the first term and the last term stayed the same. The only thing that I'm replacing is this 8x, and if you notice, those two combine to give us that middle term. And so that's kind of the idea of what we're trying to do here. Now when we factor by grouping, we're going to take the first 2 terms and we're going to take the last 2 terms and kind of group them together and kind of treat them individually and work with them alone. And so now this goes back to what we were doing before and finding those greatest common factors of each one of these individual pieces. And so here I'm going to take 3x squared plus 2x and find the greatest common factor, which in this case is just x. And then I'm going to write my parentheses and then write what's left over, which is 3x plus 2. And like I said, that kind of goes back to what we were doing before. Now I'm going to do that same thing over here. So we have plus in the middle. So the common factor between 6x and 4 is just going to be 2. And then I can make my parentheses, and then what's left over is 3x plus 2. So if you kind of look at what's going on here, we're taking 2 individual pieces, we're grouping them separately, and then kind of working with them. Now, what we're going to kind of introduce is this idea of a new common factor. Common factors don't have to be just numbers, they don't have to be variables. What they can be is they can be entire expressions. So if we kind of look at what's going on here, we have this piece here and this piece here are identical to each other. They both have that 3x plus 2, and so what this is that this becomes the greatest common factor. So we've kind of gone through this process a couple times, and so what I'm going to do is I'm going to remove that entire greatest common factor of 3x plus 2, and then what's left over goes in parentheses, and if you look at it, this and plus 2 are what's left over, so my second binomial is x plus 2. So the idea behind grouping is that we write 4 terms, we use A times C to give us the factor pairs that we're going to want to use, so that we can, take that middle term and make it into 2 different terms, so that we can factor each one of those groups and then kind of bring it back together and then rewrite it. So here's another example that we can look at. And so the idea is that we're going to take this and we're going to try to create those greatest common factors so that we can factor this polynomial a little bit easier, and we're going to kind of use the same idea. So the first thing that we're going to look at is we're going to look at A times C. So in this case we have 4 times 12 because we have A and we have C, which is going to give me 48. And so that's going to kind of be the number I'm looking at. And then I'm also going to look at B here in the middle. So I want to figure out factor pairs of 48 that will combine to give me 19 in some way. So we can kind of work down the line if we need to. So factor pairs of 48, 1 and 48, 2 and 24, 3 and 16. We can kind of work our way down there, but once we get here we notice that 3 and 16 will combine to give us 19, and so that's the factor pair that we're going to use. So basically what we're going to do is we're going to substitute 19x for the factor pairs of 3 and 16. And it doesn't matter which order that I write them, so I'm going to start with my first term, 4x squared, plus 3x, plus 16x, and then plus 12. Noticing that I kind of use color there to show that, we have 3x plus 16x is really going to combine to give me this 19x. So we're not really changing anything about our polynomial or our quadratic. The idea is that we're just kind of manipulating it in a way that we can use it better. And so now I'm going to start my factor by grouping. And so now I can use my two groups. So I have my first group here, and then I have my second group here. Notice that I kept that addition there in kind of the middle. And so I'm just going to find the greatest common factor of each one individually. So the idea behind it is I'm just going to kind of cover these up, and I'm just going to work with this one. So I'm looking for the common factor between 4x squared and 3x, which just happens to be x, and then I write what's left over, 4x plus 3. And then now I can move over to the next one. And so I have my addition still in the middle, and then so I can go look at the common factor between 16x and 12, which in this case happens to be 4. And then what's left over? 4x plus 3. And so the idea here is what we've done is we created two groups. So we had our first group and we had our second group, and what we've created then are two exactly the same binomials, and those again are going to be our greatest common factor. And so we're going to bring that out in front, 4x plus 3, put that in parentheses, and then what's left over, the x and then the plus 4. And so there you have it. We just factored by grouping, and now we have two binomials in which we could find the zeros of those if we wanted to by setting each one of those individually equal to 0 and kind of progressing that way. So it's just a different way that we can look at this, and just kind of a way that we progress through this. Now this method also works for when the coefficient is 1. It's just when you multiply a times c, it's the same result. So it's no different than if we did it the other way too as well. Now, the last example that I'm going to show you is making sure that we get our signs right. Now, in certain situations, what we're going to have is we're going to have positive and we're going to have negative middle terms, with it being positive or negative on the outside. Now, the problem that comes with this is that when we, look at a times c, so first thing that we'll look at is a times c, which is negative 12. We're going to try to find those common factors that would multiply with 12 that give us positive 1. Now, one general rule of thumb, so factors of 12, and then instead of saying factors of negative 12, what I'm going to look at is factors of 12 that have a difference of b, which b in this case is 1. So I'm looking for the factor pairs of 12 that are only different by 1. So we have 1 and 12, we have 3 and 4, 2 and 6. Now if we look at these ones, these are the only ones here that are different by one value. Now again, I told you this in the last video, we have to figure out which one is positive, which one is negative. Well, b is positive, so the larger of these two factors will be positive, so we'll have a negative 3 and a positive 4. Now when we write this out to factor by grouping, we leave the first one the same, 2x squared, and then now we're going to have to be careful with the way that we write this. Now generally what I'll say is you write positive, negative, but in some cases you can't get around that. And so I'll show you the way that we can kind of look through this. So if I do plus 4x minus 3x and then minus 6. And so now I'm going to factor this by grouping, but watch what I do with my factors, or my groupings. So I take the first two and then I take the second two. Notice that I took that negative 2 as well. And so now what I'm going to do is I'm going to create my box, and so I'll just put this over here. And so now I'm going to factor this by grouping just the 2x squared plus 4x. The common factor between 2x squared and 4x is going to be 2x. And then I'm going to put the rest in parentheses, so x squared plus 2. Or not x squared, sorry. Just x plus 2. And so that's completely factored there, so I'm going to move over to my next one. Now notice what I have here. I have a negative 3x minus 6. Now what I want to show you is, this is titled Get the Signs Right. Negative 3 has factors of negative 1 times 3. So the idea is that every negative number has a factor of a negative 1. And so when we look at this, instead of just looking at the numbers themselves, they're both negative, and so I can factor out a negative. So my common factor is negative 3. So you just have to be very careful with that. Now, even positive values, have factors of negative 3. Or not negative 3, but negative. And so if I look at a positive 6, that's technically negative 1 times 2 times 3. So we can always, what we can do is we can kind of just change the sign with those. So there's different things that we can do with these that kind of, help us get these signs right so that we're not working with negatives when we have this initial coefficient here. So the idea here is if I remove a factor of negative 3 from negative 3x, just x, and then if I remove a factor of negative 3 from negative 6, it's going to give me a positive 2. Now remember, removing factors is the same thing as dividing. So negative 6 divided by negative 3 gives me that positive 2. And if you look at what happened here, now I have these binomials that are exactly identical. If I didn't factor out those negatives, I wouldn't get that same binomial. And so now what I have left is I have 2x minus 3 and then multiplied by x plus 2. Now if you notice, I did this a little bit differently than what I did before, but if you notice, we have our greatest common factor here, the 2x minus 3, and then we have 2x minus 3. So they're still kind of, they're still accounted for. It's just we can write them however we want to. And so that's going to kind of do it for factoring by grouping.